Hey everyone, and welcome back to the channel. Today, we're re-diving into a topic that many of you Rotax pilots and mechanics have likely encountered or at least heard about, the dreaded lane. A warning. It's a common fault on the Rotax 912, 914, and especially the 915's engines. So, what exactly is it? What causes it? And most importantly, how do you fix it? Let's get into it. First, let's understand what's happening when you see that lane the lights start blinking. Your Rotax's engine has two completely independent engine control lanes, lane A and lane B. Think of them as two separate brains running the engine. Each lane has its own set of sensors, its own power supply, and its own wiring. This redundancy is a key safety feature. When you get a lane warning, it means that lane A has detected a problem with one of its sensors. The good news is, the engine will continue to run because lane B is still operating perfectly. It takes over full control, and you can continue your flight safely. However, you might notice some subtle changes. The engine might run a little rougher than usual. And of course, you'll have that persistent blinking light on your dash telling you something's not quite right. So, you've landed safely, and now it's time to play detective. Where do you start troubleshooting this lane warning? The very first step is to connect to the engine control unit, or ECU, with a diagnostic tool like the BUD software. The ECU logs fault codes, and this will be your roadmap. It will tell you exactly which sensor in lane A is causing the problem. Don't just start unplugging things randomly. Let the computer guide you. The most common culprits for a lane of fault are the temperature sensors. Specifically, the coolant temperature sensor and the airbox temperature sensor are frequent offenders. The ECU will tell you which one is acting up. For example, you might get a fault code that says coolant temperature sensor circuit high. This usually points to an open circuit, meaning there's a break in the connection somewhere. It could be a loose pin in a connector, a corroded terminal, or a broken wire. Another major area to investigate is the grounding. These engines rely on solid ground connections for the sensors to report accurate data. Check all the ground points for lane A. Make sure they are clean, tight, and free of any corrosion. A bad ground can cause all sorts of strange, intermittent electrical gremlins, including a lane A warning. A simple check with a multimeter can confirm if you have a good ground path. Once the diagnostic software has pointed you to the specific sensor, your job is to inspect the entire circuit for that sensor. Start at the sensor itself. Is the connector fully seated? Are the pins clean? Give the wires a gentle tug to make sure they're secure. Follow the wiring loom back towards the ECU, looking for any signs of damage, chafing, or pinching. Pay close attention to the big cannon plugs that connect the engine harness to the airframe. These are common places for pins to become loose or corroded, especially if the aircraft is exposed to moisture. If the wiring and connectors all look good, the next logical step is to suspect the sensor itself has failed. These sensors do have a finite lifespan and can fail internally. The easiest way to confirm this is to swap it with a corresponding sensor from lane B, for instance. If the lane A coolant temp sensor is flagged, you can swap it with the lane B coolant temp sensor. They are identical parts. After swapping them, clear the fault codes and run the engine again. If the fault now appears on lane B, you've confirmed that the sensor is bad. It's a simple, effective troubleshooting technique that doesn't require you to have a spare part on hand, just for testing. If the sensor is indeed faulty, the fix is straightforward. Replace it with a new one. Always use genuine Rotax parts to ensure reliability. After replacing the sensor, clear the codes one last time and run the engine to confirm that the lane A warning light stays off. A quick ground run and a check of the live data in your diagnostic software will give you the confidence that the issue is fully resolved. So, to recap, a lane warning means a sensor in that control lane has a problem. Lane B takes over, and the engine keeps running. To fix it, first, scan the ECU to identify the faulty sensor. Then, thoroughly inspect the sensor's connector, wiring, and ground connection. If everything looks good, swap the sensor with its counterpart from lane B to confirm if the sensor itself has failed. Finally, replace the faulty component. By following this logical process, you can diagnose and fix this common issue efficiently and get back in the air with confidence. I hope this breakdown was helpful for all you Rotax owners and maintainers out there. Dealing with engine warnings can be stressful, but with the right knowledge, they become much more manageable. If you found this video useful, please give it a thumbs up and consider subscribing for more aircraft maintenance tips and tricks. Fly safe, and we'll see you in the next one.